All right, we're going to get started. Thank you all for coming.
Huh?
No Homer. That's right. We'll get to that in a minute. Christoph, I wanted to show you some of the work that we did on Pulp. We got it all wrapped up into containers, and I just got the documentation together. I just wanted to walk you through it.
So just a quick question.
Sure.
Do these guys know that you are my dev guy? That you
Right.
write
I'm
all
the developer.
Right.
And
Thank you very much.
and he's.
I run your stuff.
That's right. He runs.
I hope to run your stuff.
He's the ops guy.
Ops guy. Thank you very much. We got no stickers. Sorry for that.
There you go.
Right. Right.
So I pulled together all the Docker commands you need to run. All you need to do is copy each one of these out into and paste them into the terminal window, and you can run. It's really cool. So I've got all of the microservices. So the messaging, the Mongo database, the front end, and then there's some distributed task queue workers that are all run through all these commands.
I see. Okay. And
yeah.
I just take that command, that list of commands, copy and paste them into my console and run it, right?
Right. Well, you need that environment variable up here, and then yeah, you literally just copy. So it's a little tricky, but you just copy it all the way over, like this. Yeah. You just copy it, and then then you go to a terminal window and paste it. So all right.
So did you get the right command? I mean,
well, hey, we're just a demo.
Yeah, just copy and pasting stuff into a running system feels like maybe you copied
right.
too much.
So, and that's why I did all the orchestration work. So we pulled together all this stuff into a Kubernetes metadata. So the cool thing with this is all of it's basically taken care of for you. Kubernetes will manage all of the services and the pods and make sure that they're running in a distributed system. And all you have to do here is change, see this change me here?
Yeah.
So that's the public IP address of each service. And so all you have to do is open up each one of these files and change that, and then you can deploy it.
I mean, we're pretty good at putting in variables by cut and pasting. That's reducing our work a little bit. Right. But I need to open up all these, what is it called, YAML files, right?
Right.
I need to open them up and put them on my server. And
right, yeah. Yeah, and it works pretty well. I mean, you have to be careful, but you can run a validator to make sure you didn't screw it up or something. And then also with the replication controllers, you need to add a SSL URL and then a IP.
How many of these change me's you got?
This is eight changes.
Okay.
Yeah, okay.
So you can send over an Excel sheet to me with that.
Yeah,
right.
And we could probably write some sort of shell script or something. Maybe do you know how to use sed? Maybe you can use sed or something.
Yeah, right. Okay.
And then all you have to do is copy and paste these commands to run Kubernetes, and this will create all the services and pods and that type of thing.
I think I will have one of my guys who's doing development stuff for us and maybe put that in a shell script too.
Yeah, maybe. So the one thing I'm not sure is how do we get these to our customers? Because we're trying to get all this stuff. So we got all the containers on Docker Hub and in our registry. So I wasn't quite sure.
Yeah, but I mean, we got to clone the GitHub repository so we can ship it.
Yeah. Well, we could just put them in a tarball, so then they can just run extract the tarball, and then they can run these things.
And they download the tarball from your website.
Right. It'd be like a right-click download, type of thing, or they can curl it. Worst case, we wrap all this into an RPM, and then they can yum install the metadata, and then they can run it. That's not too bad.
Okay, let me shortly wrap that up. We got the GitHub repository containing the README, which is about, I don't know, I haven't counted, but feels like 500 lines or stuff like that.
No, it's only 360.
Yeah. Well, thank you very much. And so we got the README on the GitHub repository. We put up a tar file or an RPM on our website. We just cut and paste all that YAML files into something, like my service. Right. And then we use that or whatever to replace some variables.
Yeah.
And then it's up and running.
Yeah, you're making it sound worse than it is.
Yeah, I know that. Maybe you can kind of switch back to the other presentation. And because I've prepared that, because I know it feels a little bit confusing, and maybe all of you guys have had that conversation somehow before, maybe with dev, maybe with ops. But I think in the end it turns out, and the point was kind of clear, that I press spacebar, that you got a massive amount of containers and that you need to do something with that. You need to take them from here to there into production. You got to parameterize these containers. This is basically where Docker kind of lacks something. They provide a cool format to transport software stacks from here to there and run these software stacks independent of each other. But they have not, until yet, thought about how to keep these things in exactly the customized form that the customer needs these things. So what we've experienced is that containers are great to deliver software, but I think it's written on his shirt. In the end of the day, we need to ship some applications, and that applications may be 20 containers. I don't know, the pulp example you gave is like 8 containers, which need to be parameterized, which have some kind of dependency and all that stuff. So having a multi-container application and having a good colleague switching on to the next slide will lead us to some simple statements and the core of what we are working on. We try to deliver some application to our customers, maybe an internal customer, like from dev to ops, maybe an ISV of Red Hat, which we enable to do that, maybe some software from a third party. But we try to give these developer guys an additional description of their application, of all their dependencies. So that is what everybody loves, at least everybody on the stage loves, and that is what is called the Nulecule. That is a specification which is trying to describe an application in its completeness, which tries to deliver an application in a container format, because that is one of the things we were told to do. Don't send around RPMs plus READMEs plus some download links. Just deliver a container to the customer. So we wrap everything up in a single container, and we put some dependency information in that in that container, so that we know that the pulp application is using a database, is using a messaging infrastructure. Maybe there's additionally a web server we need to use. We put all that dependency information into the Nulecule, or the atomic app, and we have some orchestration metadata. How to run all these containers on Kubernetes, or how to run all these containers on OpenShift v3. So in the end, we would like to enable the operational guy to just call one command and get the information from the software vendor, and have another command to deploy it onto his infrastructure. And I think that is where Wojciech will start. That is an installer for ISV application. So Wojciech, he's from the Brno office, which is in Czech Republic, Europe. Sorry about that. And he has developed much of the software we are running on. So all that stuff is up on GitHub. I think we'll distribute all that information to you. Have a look at it, play with it, and come back to us and contribute.
Okay, so as Christoph said, we need an installer. Nulecule is a specification, so we need some kind of implementation for this specification, and that implementation is Atomic App. So it's a tool to run Nulecule applications. It's written in Python. It has concept of provider plugins, which is something that Nulecule that will let you to run your application not only in one orchestrator, but in any that is implemented in your in the Atomic App or any other implementation that will appear. So if you want to run in Kubernetes, you will use plugin for Kubernetes. If you want to run in OpenShift or Docker or Mesos, there will be plugins for that. And Atomic App is also shipped in a container because we want to have everything regarding containerized applications. We want to have everything in a container. And this is basically how you create your application. You will take a base image of Atomic App. It's on Docker Hub, project atomic /atomic app, and you will add to this image your application metadata, which is a Nulecule file, Docker file, and artifacts that that describes how to run the application in a specific orchestrator, like Kubernetes. And you'll build a layer on top of the base image. So if you do that, you have your application, you have your atomic app image. Then if you want to install the application, you call atomic install your application. And what happens is that inside the image, there is also the binary for atomic app, as I already said. It will unpack the files, the Nulecule file, Docker file, artifacts, all that stuff. It will unpack that. It will dispatch the graph, so basically go through the dependency chain, pull all the dependent components of the application. So if, let's say, you want to deploy WordPress, which is an awesome example, right? So you want to deploy WordPress. There is WordPress image, WordPress application, and there is a MariaDB application. So you depend, your WordPress application depends on a MariaDB. So Atomic App will pull the MariaDB application for you, and it will basically recursively do the same thing for MariaDB as it did for WordPress. The thing that then you can find on your disk is all these Nulecule files for the application and for the components, and the sample answer files. Answer file is a way how to provide to Atomic App the answers for parameters. So if your parameter, as Aaron showed, wants IP address, public IP address, you can write it to answer file, and when you run the application, it will take the answer file or the value from answer file and use it in deployment. And then when you run that, you change the sample answers to your specific answers. You can have multiple of them. So if you need some answers, some parameters, specific parameters for development environment, some for QE environment, and some production. So I guess that public IP is a good example because that will change for every deployment to every specific environment. So you can have multiple of them. You can have many of them. So Atomic App will take these files, go to a provider-specific code, and it will deploy to a specified provider. So in answers, you can also specify which provider you want to deploy to. So if you want to go to Kubernetes, you say provider equals Kubernetes, and it will deploy to Kubernetes. Yeah, I think that's it.
Any questions up to this point?
So I learned that answers are translated further into more detailed answers specific to whatever that is. So who translates it? Is it the provider plugin as a translator, or is it a generic translator?
Yeah. Yes. So the question was who translates the answers. So answers are general for the application. So if you have parameters for every component can have parameters, and answers are mapped to these components. It is not provider specific. So you can use. So if you specify public IP and you have this public IP used in any provider artifacts, it will be used there. Does it answer your question?
So I thought you said if I give a brief answers, can this atomic engine or something inside can further translate that answer into minute details and translate into 10 different, one answer translates into 10 different answers. Is that possible, or answers are just passed on?
Maybe we should do our demo, and then it'll be a specific example. Maybe that'll answer your question. Any other questions before we do the demo? So we have a project called Cockpit, which is a web UI for a system. In this case, I simply have one system. It's been configured for, it's an atomic system that's been configured for Kubernetes, and so I can deploy things to a Kubernetes cluster. I currently have no services, and I have no containers running on this server. And I also have I'm going to refresh this. I also have an application that's not running, but will in a minute. Let me just take you through the files, the metadata files, before we launch it, because it's actually pretty quick. Well, all good demos are quick, right? So we have this guest book application, which is commonly used up on the Kubernetes examples directory in the Google examples directory. So, the README for this thing is, it's about 300 or 400 lines. I can't remember what it is, and that's kind of where we came from as we were doing our work and seeing other people's work, trying to explain how to deploy these things. So what we've done is we've done basically pulled all of the Kubernetes files into a directory, we're calling these artifacts. So these are like provider-specific artifacts that you can use to deploy. These are the kind of the objects that you develop, and we're then referencing these things in a Nulecule file. And this is what we've been talking about. So it's a fairly simple YAML format, can be JSON as well. There's some metadata that can describe the thing and versioning and those types of things. But really, the interesting kind of working pieces are this graph. So the graph is a set of components that are going to be deployed. So here we have two items in the graph. We've got this guestbook front end, which is a web server, and we have some parameters for this front end. So the actual image that is going to be used, we provide defaults, right? So these are things that unless they're overridden, they'll be used. Default IP address or default port, and then the IP address is there's no default provided. So that's going to be something that's required at deployment time, right? And then in this artifact section, we have one provider. But we envision, you could have many providers. You could have Kubernetes, straight Docker, Docker Compose, or OpenShift, as has been mentioned. So here we've just referenced the Kubernetes files that are local to this repository and can be deployed locally. Then this other component, if you'll notice, this is a Redis service. It's a key value store service, and it is actually a reference of another Docker image. This Docker image is yet another atomic app, okay? So we envision this as being like a library of things that you can pull off the shelf as a developer and not have to redo, not have to redevelop from scratch your databases, so these common services. You really should be able to pull something that's well designed, well parameterized, and ready to go in your project. So you notice there's no parameters here. All of the parameters are inherited, and all of the artifacts are inherited from this project. So let's just take a look at that Redis example really quick, and then we'll get into the actual demo. So here we have this Redis service. I'm going to show you the Nulecule file. In here we have, it's a more complex application actually. It's got several components. Other artifacts, there's actually 4 Kubernetes artifacts. There's some parameters that are defined. So these things, whenever we run the guest book, will be inherited, will be pulled in, and rendered. All the parameters will be rendered. So let's take a look at, in our Cockpit, we're going to say deploy. We're going to deploy a Nulecule application. And we're going to just give it a Docker image, right? Because we don't want to pass anything around that's outside of container technology. So project atomic guestbook go-app. And someone give me a namespace. What did you say? Towel. All right. Did you make sure I got this right? Yep. So we say deploy. So what's it's going to do is going to pull down this application that Vašek told us about, and it's also going to get the metadata that was built on top of that. Okay. And once it pulls all this down, it will then pull in any dependencies, right? Because we have that Redis example as well.
And shall we talk about the quality of the wireless network?
So I actually cached all these, so this should just work. So let's just just make sure I got all the. Yeah, it doesn't look cached to me. Did I spell it right? Nice. So this is a local. Yeah, let me just check the. I have a bunch of images on this thing. In case I pulled it in wrong. Let's do this again. No containers, deploy. Well, the other thing I can do, get pods. There's no pods, there's no replication controllers, services. Oh, there's this Kubernetes service. All right. And our namespace is towel. Deploy. So one of the things that we're really excited about is it solves it's actually a relatively simple process to kind of wrap these things together, and it gets us so much. So we get an installer, we get this parameterization concept, and this kind of self-defining. Nice. We get this kind of self-defining set of parameters so that you can provide user constraints from the, whether it's alphanumeric type things or length of parameters, that kind of thing. So the user experience can be pretty reasonable, whether it's a command line or a web UI driven thing. I don't know what to say here. Let's try.
Is it missing the leading .io?
Yeah, it shouldn't. That's a good question. Right before this, it was working fine. Project Atomic. Let's try a different namespace. I don't know if. Loadinganswers.conf. Why is that? So yeah. It's interesting that it was. Yeah. Right. All right. Any questions while we're watching paint dry? Yeah. Yeah. This is a pretty kind of work in progress. This Cockpit UI support for Atomic App is really new, so it actually came from the. Yeah, I got it from Steph Walter, the primary developer on Cockpit. So he's. Yeah, it's Right. Yeah.
So let's have a look at the answers file.
Yes.
Yeah.
Yeah. So here's.
So I think the thing is that the answers file is processed. We walk through the Nulecule file, figure out what information is needed to deploy the application, right? And then we write that out into the answers file that is called examples or answers. Examples. Yeah. So you have not a template, but an example what information needs to be inputted. You can simply copy that file because you are happy with all the information, or you can edit the file, copy and edit the file. So you can put in the Redis ports, and I don't know what we need for Redis actually. And then you can put in the public IP address. And this single answer file is then processed in the atomic run step. This single answer file is processed to parameterize the pulp application itself. Public IP address will be put in there. And it will be taken to the Redis stuff for the server, number of slaves, I think they call it slaves, number of slaves, and all the parameters that are required by Redis. So you get one answers file per environment. That is what Wojciech said. If you have test, stage, production, you have 3 answers files, but you get one answer file per environment to parameterize the whole application, including all its dependencies.
So the answer file is generated by the atomic app.
Sorry, come again, please.
Answers are conf generated by the atomic app.
Yeah, correct.
It will create for you answers.conf.sample. You don't need to rename it to answers.conf and change it if there is anything. If you don't need to change anything in that, you don't have to change it at all.
Yeah.
All is inside the application when it's run. But if you change something and you need to rename it, then
And what you see now is a super simple answer file. You simply select the provider you're going to use. We deploy to Kubernetes, so that's the only information that is needed.
the YAML file that you showed is what defines the complex app.
Right, right. Including dependencies and all that stuff.
Right. So the answer file is actually rendered. Yeah.
But you mentioned that you are going to deliver the whole app as one big container that has all the things. So I didn't see that.
Yeah, so the question was, where's the one container we are talking about? Maybe we switch over to Docker
No, we
Hub.
can do. Why don't I just run it here?
Yeah, just go ahead.
We got atomic here, right?
Sorry?
Um,
Don't know.
there's some. I think this might be a problem with network of the VPN. but
it
if
could
you
be. You know, the other thing.
Just,
Let me just restart
suspend your
Kubernetes.
computer, wake it up, VMs, and Docker in those VMs, all lose connection, and it starts to behave very weird.
And actually, you migrated the laptop from the test environment table over there to
Yes.
the production environment. That is always a tricky thing.
It's like 10 meters.
It is.
Just want to look at some logs here, just make sure.
So what Aaron is going to do, he's going to clean up all that Kubernetes and Docker and all that stuff. And maybe we simply use the console.
Aha! Host IP.
Yes,
Yeah.
I told you, network. So, I think you need to remove or something.
6.8.
You're running Kubernetes.
Yeah. Alt F4 will do it.
Can I ask another question? While
Yeah, sure. Just go ahead.
So, do you allow labels to be attached to this big app as a whole?
So the question is if we need to apply some labels to the application?
We can apply.
Yeah, that's a different thing. I don't know.
Not yet.
Not yet.
There's an issue.
So if you look at our GitHub repository, we have lots of open issues. It's bad to call them issues. It's features, requests, and stuff like that. And one of this is that we want to put a certain number of labels you specify in the answer file, right, on all components of the app, the Atomic app. So if you see Redis, master and slaves, and you have a label called my super fancy pulp installation, we would apply that label onto all components. I think, yeah, should be done for Red Hat Summit, but we were stuck in preparing some presentation, actually.
Yeah, Nero's.
Yeah. So expect it to come. It's kind of an easy thing because we have the Kubernetes object tree, and we can simply apply additional labels to that and deploy that.
Is labels a Kubernetes specific thing, or since you have multiple providers? So Kubernetes is all about labels, right? You do a lot of things with labels, but another provider may do something else.
That's true. So, I mean, you need to translate what a Nulecule label is into what a real provider makes out of that. So OpenShift has the concept of labels. You can label each and everything. Kubernetes has the same. Docker has not the concept of labels. I mean, we can map it to the name. So our Docker provider could take the label and append it to the name of the Docker container itself, maybe. So
the translation is done by the Docker provider. The translation, let's say you have.
yeah, correct, correct. So the atomic app logic itself that is inside of the container, evaluating the answers files, needs to tell the provider what to do with it. So the Docker provider is pretty dumb. It just takes that image, parameterizes it a little bit, and says basically Docker run. And if we want to apply labels onto Docker provider things, we say we want to prepend the label onto the Docker container name. Then the provider needs to implement that logic. Right.
You still have support for super privileged containers and the install and uninstall that was previously part of Atomic as well. So this would provide a super layer above that?
Well,
Yeah.
no.
No. Can you rephrase the question a little bit?
Previously, it actually had support for basically packaging and install and uninstall snippets inside
Yeah.
a single container app.
Right. So the question was if the Atomic tool, if we plug into the Atomic tool into these install, uninstall labels. I think that's what you asked, really. So we use that label, so you can't. So.
No, but in your container, but the subcontainers.
Right. The subcontainers
Yeah,
are.
you think about it. Identity management server, for example.
Right.
Command line's about yay long.
Right.
You don't really want to rekey that, and it's already packaged in if you're using the Atomic concept in that particular container.
So I think this is a matter of how Docker provider should work. Currently, it just expects you to give it a file with a single line, and it's a Docker run command. But that was just really proof of concept. I think it should use labels that are in the image. So
Yeah.
yes, this is just a matter of what we expect from Docker provider. This might be, and if we have a Docker provider that does not do this, it's just a matter of implementing another provider that will do that.
As I said, our Docker provider is pretty dumb. It's just Docker run, so not that fancy. And container images get parameterized and run on OpenShift, for example, in a complete different way before their parameters going in that OpenShift configuration. So they don't do any atomic run on OpenShift.
It's getting messy because then you've got different format containers depending on who the provider is.
No, that's capsuled in the artifacts.
You've got a different provider for every environment, and then you encapsulate all the specifics
Right.
for that provider in that provider implementation.
No, but if you build applications in layers, right? So you may have a service, I think in the Pulp, it was very much like that. And so when you start looking at it, you literally want to pull a component off, and that component will definitely have startup scripts and such related to it. I mean, even in the worst case, if you're running Atomic, you have the system D, to start that container up at boot time. I mean, there's a lot of things to do. And you don't want to take that level information for that one set of containers and then pushing it further up. You want to make it
Yeah, that's
so you
true.
can build it hierarchical, right?
Yeah, that's what we actually do. We take that Redis, that plain Redis thing, the container that is able to start the master on many slaves, and we deploy to OpenShift by applying OpenShift strategies. Having that configuration file, we call that artifacts, and configure OpenShift to that. I think what you're looking at is that atomic run tool and the Docker thing, and there you need that nesting, and we don't want to push the logic up because we want to keep the logic in the lower level, because Redis knows how to start itself.
Yeah,
Redis
what I'm
knows.
saying.
Yeah.
I want
Right.
Redis to only know about Redis.
Yeah, we don't take it away from that thing in that simple case of atomic run. Yeah. Oh.
Do the provider plugins also handle authentication as a provider? Like how does that work? Like, for instance, with OpenShift, if you're trying to deploy something into it, you need to have an account.
Yeah, right.
So how does that all get done?
So I translate your question in how do you parameterize a provider? How to get the OpenShift credentials into the OpenShift provider, right?
Sure.
Yeah. So parameterizing providers is obviously done. I think by now we, yeah, correct. So for the OpenShift example, by now we take the, what is it called, OpenShift config file, where we got all that certificates and all that stuff in there, and need to provide it additionally to the answers file. But in the future, we try to get rid of that because we need to provide more and more and more information, which makes no sense to at least to us. We would like to have, in the atomic app logic, a thing that is just being told, that is the OpenShift master, that is the credentials, go ahead. So we need to interact with the deployment target platform. But by now, it's pretty simple, especially in the case of OpenShift. We reuse the command line tools, we reuse the configuration files. And that is what the provider is about. Use these two things and talk to OpenShift. Right. So, yeah.
Can we use the option now to control the database credentials?
Yeah, so the question was, can we put database credentials into the answers file? Yeah, that is exactly the use case, what it's used for. You can specify that the Redis credentials are like this.
On the server side and then also on the database side.
Yeah, right, correct. While at deployment time, that is a step where we call atomic run our application. At that point, the answer file must contain all that information, and these get applied to the tree, to the atomic app. Yeah, right.
All right.
Do we need to check in?
No, it's like a configuration file for the deployment process, for the deployment step. Right, you don't check it in somehow. I mean, you can do that, obviously, but we are not required to have it in some repository. It's just sitting there on your workstation. You edit it, you use it, and then you get rid of it, maybe, or you check it in for some other reason. But
we use the command line override that?
yeah, correct. You can do that. I mean, you're free to generate the answers file automatically by yourself. I mean, if you have some database where you specify all your Redis credentials, whysoever you do that, you can write a little script that is getting all that information from your database. Some people call that a CMDB, like configuration management database, right? You get it from there, write it in an answer file in an automatic way, call atomic run, and then it's done. So
We're playing the video.
oh, right, yeah.
This is an answer file that came up.
Can you make it a bit larger somehow?
No.
No. Oh, sorry about that.
So,
So we put the link of the video in there, right?
yeah.
Sorry.
Yeah, so we're just filling out the parameters. There was an opportunity to override defaults. The public IP address was left empty. It's a required parameter. And then when it deploys, in this case, we're running Kubernetes. And so it simply runs the Kubernetes commands to create the services and replication controllers. The nodes then are actually pulling down the binary code containers to actually deploy the thing. So it's really difficult to see, but essentially, he's got this guest book, application that comes up. So. Yeah, it is. Yeah, it is. I'm playing this from YouTube right now. Yeah.
What's the title for those first two?
Right. Wish I could. Oh my gosh, it's working. Hang on. Jeez, I'm so sorry, guys. I'm just going to put in the IP address of the local machine that I'm on. I don't want to screw this up. And we got namespace towel.
So this is basically the step where you fill in the answers into the answers file, right? So that
UI is writing out their answers files now. And then is going to deploy that answers file.
So this UI is part of the installer?
No.
This is just Cockpit. This is a separate project.
This is one graphical front end to our implementation of the Nulecule specification. We can use it on the command line. That is like 2 commands, like atomic install something, atomic run something. We can use it in Cockpit. I think there were plenty of Cockpit calls. It's a little piece of functionality inside of Cockpit to deploy Nulecule applications.
As you can see, the containers are now running in this graph, and we can go to our, I'm going to refresh this. Oh, it's 167, hang on. Yeah, and here's our guest book.
So the parameters that you typed in on the screen there somehow substituted into the Kubernetes manifest by the provider.
That's right.
Right.
Yeah.
So what does the Kubernetes manifest look like then?
Right.
How do placeholders?
So there's, what we have today is not where we want to be, but what we have today is simply a $ replacement. So you actually, provide a $, and then a parameter name in the Kubernetes files. Let me just pull up the Redis example. But what we would like to do is to have more of a, you bring your Kubernetes files unaltered, we will use like XPath style replacement, because it is a data structure that you should be able to just change any value, really. And so the goal of the, I think this is one here. No, the goal of the application developer will just be to select which parameters to. Sorry, I'm not seeing the. Master service. Yeah, so like here's image, like $ image is exposed as a named parameter in this wherever the artifacts are pulled in. So it's a pretty basic rudimentary type system right now, but yeah, we'd like to be able to just do kind of an XPath style.
Something called JSON reference, and by that you can reference any structure in the JSON file or YAML file the same way as XPath. Yeah. So this is where we should go, because changing the Kubernetes files or artifacts doesn't make sense because you have to carry copies of those from upstream.
Right.
You have to pull them down, change them, so it does not help you with not having to do the work.
What needs to ask comes from the YAML file that you showed me. Like now we need to install
Yes.
Correct. So the artifacts in the provider needs to correspond to the YAML file, because in that
So you see
example,
here, there's an image.
yeah. I mean,
This corresponds to $ image. It will be rendered, in whatever application, whatever it's the command line that accepts the params file, or a UI that the Cockpit has implemented, OpenShift, whatever it is, will render all these things and require user input.
So all containers make that the remaining containers have use the same consistent parameter so that it likely gets them.
yeah, if you do it like that, but you can develop your own container and completely mix that up. But there are some good practices how to do that, right?
Yeah. Any other questions?
File locations in the Kubernetes artifacts is related to that super container you're talking about.
Yeah. Super container.
Like super-
We have had the name metadata container, but super container is
Right.
also good.
Right. Yeah.
So we are picking up your ideas.
So there's a blog post I've been working on all the different types of containers, and we see a lot of different patterns emerging for tools containers. Maybe they're command line type tooling. There's system containers that run alongside maybe their agent type services. There's things that we think of as traditional kind of containers, like web services and that kind of thing. So there's a whole lot of different ways of using containers, and we don't feel comfortable referencing in the same way. So we're trying to kind of find language to talk about these things and to, how are they managed differently? How are they run differently? We envision some things are run by systemd maybe, or some things are run, by a command line, and others should be, deployed by some catalog service like OpenShift, which is expose services. So lots of different ways.
So before we close the session, I at least have 3 things. Any further questions, first of all?
One last question. You consider OVA format because access file looks like pretty standard. So if you consider OVA as a format rather than having another container.
Yeah. So the format of the answer file, that was a question?
No, not that. The packaging of the application, what is the metadata container.
Yeah.
You consider delivering that as an OVA format rather than a container format.
No. One of our goals is to like, if we're deploying containers, let's use containers. We'll be all in, right? If you're already managing containers and you're already, using that as your deployment mechanism, then we now have a packaging format that is platform agnostic, can be easily managed using tools that are emerging, and the Git repositories and the tarballs and the RPMs and all these other things, we really don't want to expose to deployment at deployment time, right? And passing things around, we want to be a container. Because you can pull this thing down from anywhere in the world and run it, like it'll just run, right? Assuming the platform works.
If you got some internet.
But you know what I'm saying? It's a pretty compelling.
Yeah. We are running the metadata container because it contains a piece of logic that is translating all that stuff and containing all the artifacts.
The logic is the provider.
Right. And a little bit of glue.
If you have any more questions, why don't you talk to us after? You had 2 other things?
Yes. One other question? No question. Good. The second thing is check us out on GitHub. It's GitHub Project Atomic app. That is Nulecule. So that is the sub-project of Project Atomic. And the third thing is rate us on the Summit app. I don't know what it's called. Red Hat Summit app. So we need your feedback. Do you like that style of presentation, or shall we just put 500 PowerPoint slides on you? I don't know if you're used to that. Is it good that's interactive like that? Please rate that session, this particular session. And that's it.
That's it. Thank you all.
Thank you very much.